In this video, we're going to look at operations on sets. List the elements in the sets described below, then find the number of elements in the set. So we're given U, the universal set, which is the letters from A to J, and A, B, and C. The sets have their elements listed. So let's look at A, the elements of U that are in the set A and B. So notice the connector here is AND. So AND for sets means intersection. That's the name of the operation. We're finding the intersection of A and B, and then it means that we want the elements that are in both sets. Okay. So here I've listed the sets A and B, and what we want to do is find any elements that are listed in both of the sets. So let's try to be systematic about this so we don't miss any. Okay, so I'm going to start with the set A, look at each one of its elements, and if it's also in B, I'm going to highlight it. So the first element in A is lowercase b. That's in the set B, so I'm going to highlight it. Then the lowercase letter D, which is also in the set B, so I've highlighted it. E is in the set A, but it's not in the set B. H is in the set A, it's also in B, so I highlight it. And J is in the set A, but it's not in the set B. So there are 3 elements that I found that are in both sets. If you want to double check your work, now you can look at the set B, look at anything left over, and just double check that it's not in fact in A. So we found all the elements in both, and we're going to say A and B equals, put curly brackets and just list the elements, B, D, and H. We were also asked to find the number of elements in the set, so you count the number of elements, which is 3. So A and B has 3 elements. Let's look at the next one. The elements of U that are in the set A or C. So the connector here, we're looking at the sets A and C, and the connector is the word OR. And in set theory, that means union. So we could also say the union of the sets A and C. Okay. It means it's in A or C or both. Okay. So basically this is all of the elements that we see listed here. However, the one thing we need to be careful of is, remember, in sets we don't ever list an element twice. An element is either in the set or not in it. So if it's in both sets, we'll only list it once. So A or C. Now a systematic way of doing this is I'm going to start by listing everything in A, because A or C contains everything in A. So B, D, E, H, and J. Now I'm going to the set C, and if there are any elements that I haven't already listed, I'm going to add them to my list. So the letter C is the first element in the set, capital C. That hasn't been listed yet, so I'm going to add that to the list. The next element in C is D, but I already listed that. F I have not listed yet, so I'm going to add that to my set, and I have not listed yet. So A or C has the elements B, D, E, H, J, C, F, and I. It's customary to write these in alphabetical order, so we'd make it B, C, D, E, F, H, I, J. Okay, just like these are listed in alphabetical order, it just helps you keep track of the elements in the set like we've done here. But it's not necessary. And now let's state how many elements are in A or C. A or C has 1, 2, 3, 4, 5, 6, 7, 8 elements. Let's look at the next one. The elements of U that are not in the set B. So the operation word here is the word not. Okay, And that's thought of as an operation called the complement. Okay? Meaning that we want all of the elements in U that are not in B. So if we put B and not B together, it would equal U without any overlap. Okay, so our method here is we're going to look at the set B and cross out every element in B that's in U. Okay, all of the elements in B are going to be in U because it's a universal set, but to find the elements that are not in B, I can just cross them out of U. So I'm going to cross out the element B, C, D, then we have F, H, and I. So I crossed out all the elements in B, and now I'm going to circle the ones that are left in U. Okay. So when you're given a not operation, a good method is to cross out the ones that are in it. Okay, and then we circle the ones that are left, A, E, G, and J. Notice none of those are in B, so they're in the set not B. So not B equals the set that contains A, E, G, and J, and not B has 4 elements. And finally, for letter D, we are asked to find the elements of U that are in the set B and not in the set A. And we can think of this as the operation of what we call minus. So here we'll write B minus A. Okay. Now notice there is another direct way to find this, but I want you to think of this in another way. We could find the set B, find the set not A like we did here, and then see what elements are in both. But let's try to think about this another way. We want all of the elements that are B, but not in A. So that means we could use this same idea here. We might call it a relative complement. So we're not looking at the set U, we're looking at the set B. And if it's in A, we're going to cross it out. So we want all the elements in B and not A. So B is in A, cross it out. D is in A, cross it out. E is in A, but it's not in B, so there's nothing to cross out. H is in A, so cross it out. So the elements that are in B and not in A are C, F, and I. And this may seem somewhat familiar. Notice B, D, and H in the first problem when we found A and B, those were the elements they do have in common, whereas B and not A are the elements that they don't have in common. So B and not A equals the elements C, F, and I, and has 1, 2, 3 elements.